I'm really happy to be chatting with Professor Stephen Fleming, kindly introduced to Anna by Mookie Lee Menuhin. Professor Fleming is joining us for Anna's first of the podcast series, Spreading Neuroscience for Social Good. Hi there and welcome. Thanks so much for joining me today.
Yeah, it's a pleasure to be here.
By way of introduction, Stephen is a Professor of Cognitive Neuroscience at UCL and a Wellcome Trust Royal Society Fellow at the Department of Experimental Psychology, Group Leader at the Max Planck UCL Centre for Computational Psychiatry and Aging Research, and a Principal Investigator at the Wellcome Centre for Human Neuroimaging, where he leads the Metacognition Group in cutting-edge multidisciplinary research as the world's leading expert in metacognition. Your latest book is devoted to this work, which we will be poring over today, Know Thyself, the Science of Self-Awareness. So first of all, congratulations on your latest book's success and for taking on the metacognition research paradigm. I think in scientific literature, it's been somewhat neglected, going back to Descartes up until about the last 50 years or 60 years. I think 1950s, 1960s. For the benefit of our listeners in getting started, can you tell us what your definition of metacognition is?
Sure, yeah. So metacognition literally means cognition about cognition, or thinking about thinking. So how we reflect on and monitor what's going on inside our heads. And I think it's often useful to introduce it with a couple of concrete examples that we might be familiar with. So if you are revising for an upcoming exam, you might think to yourself, do I know this topic well enough or not? And that's a metacognitive judgment about your knowledge, about your memory. Or in a more mundane, everyday example, if you think to yourself, well, I'm going to the shops, I need to write a list so I don't forget what I need to get when I'm in the supermarket, but then you've intuitively made a metacognitive judgment that your memory won't be quite good enough to hold in mind those 10 or 15 items. And then you can think of metacognition as operating across a number of different domains of how the mind works. So in the case of perception rather than memory, we might think to ourselves, hang on, our vision's getting a bit blurry, so maybe we need a new pair of glasses. And when you go to the opticians, they will be asking you a whole series of perceptual metacognitive judgments. They're not asking you necessarily just about what you see. They're asking you, does your vision seem clearer with this lens or with this lens? And so those are all judgments about how our minds and brains are working. And hopefully it's intuitive that how good we are at making those kind of judgments affects how we succeed in life. If we realize that we might be failing at something, we can take steps to put in place support that we might otherwise not seek out. So in the case of the optician's example, the payoff is obvious. If I've got good metacognition about my vision, then I can get the best pair of glasses for correcting that. In the case of memory and studying and revising, it's all a bit more complicated. But again, the idea would be that if we realize gaps in our knowledge, if we realize our studying is not so effective, then we can take steps to correct that. And as you said, the philosophers have been interested in metacognition or self-awareness for thousands of years. But it's only been relatively recently that we've had the tools to begin studying and quantifying metacognition in the lab. And this goes back to work in psychology in the 50s and 60s, where psychologists started being interested in what people knew about their own mental processes. So asking them questions, are they going to succeed or not on a particular task, and asking them questions about, whether they how confident they feel in their answers in simple experiments. And using those kind of data about confidence, about feelings of being able to succeed, you can then build up a picture of how good your metacognition is, because intuitively, if you're more confident when you're likely to be right and less confident when you're likely to be wrong, that shows you have a good degree of awareness or insight into what you're doing.
So from listening to what you were saying, the building blocks seem to be Judging uncertainty and self-monitoring, self-reflection, and thinking about thinking. So theory of mind, is that right?
Yeah, absolutely. So in the book, I step through a number of components of a fully fledged metacognitive system. And some of these components are shared widely with other animals. We know from studies of uncertainty and error monitoring in other species that the ability to track confidence and uncertainty seems to be a basic feature of how brains work. If we couldn't track uncertainty about our senses, for instance, we wouldn't be very good at perceiving the world. Similarly, if we couldn't realize that we've made an incorrect action and have the ability to change course based on making an incorrect action, then clearly we would not be able to survive for very long. And I think the one interesting thing about metacognition, though, is that it gives the organism the ability to correct its actions, to realize how confident it is in any phase of its life or what it's currently doing before it gets any explicit rewards from the outside. So that's really the hallmark of metacognition, that you're, in a sense, self-realizing that you might have made an error, or self-realizing that you're on the right course. Now, those kind of signals might come out of actually quite simple machinery. There are nice models coming out of the reinforcement learning literature and the literature on deep neural networks suggesting that signals of confidence and uncertainty kind of come for free with systems that can take actions as they learn what is the right or wrong thing to do in simple environments. And we see similar signals that track uncertainty and confidence in non-human animal brains when scientists probe those circuits using single unit recordings. So there seems to be a kind of a wide set of building blocks that are widely shared in the animal kingdom that allow tracking of uncertainty and monitoring our actions. But there also seems to be something extra that appears perhaps unique to humans, but maybe shared with our closest primate relatives, which enables us to consciously think about our own minds. And that seems to share neural machinery with thinking about the minds of others. So one hypothesis there is that essentially we're using similar tools, but applying theory of mind to ourselves to think about ourselves. And that's very much still a hypothesis. And it's one that we're actively testing in the lab, but the jury is still out on how that more explicit level of metacognition actually works.
What kind of experiment would you do then? Well, for theory of mind, or for even monitoring sensitivity measure, if you like, of metacognition? How would you do that in your lab?
Yeah, so we typically do those kind of experiments by asking people to do a difficult task, computer-based task, that involves either judging something perceptual, so saying, for instance, which box contains more dots, or making a decision based on some information, either held in memory or from as you learn, which option is the right one to take. And then the crucial thing is we then ask people a subjective judgment about how confident they are in getting that first decision correct. And when we have lots of those subjective judgments over time, we can then build up a statistical picture of how your confidence tracks your performance. So if you tend to have higher confidence when you're actually correct on the primary task and lower confidence when you're wrong, then that is what we call having a good degree of metacognitive sensitivity. And we and other labs have found in a number of studies now that the structure and the function of the prefrontal cortex in the human brain is important for supporting good metacognitive sensitivity. And a first wave of studies in cognitive neuroscience looked at individual differences in metacognition. to, in a sense, look at the variants related to brain structure and function. And it was found that these individual differences are relatively stable. You can test people on 2 different days and you get a retest reliability of around 0.7. So you have a reasonably high correlation in your metacognitive sensitivity over time. It seems to be a feature of an individual. That also seems to generalize across different tasks that you're doing. So if you have good metacognition about a perceptual task, for instance, you're also likely to have good metacognition about a memory task.
What about across age? What about across time?
Across time?
Yeah, so as you age, what happens?
Yeah, developmentally. Yeah, so that's an interesting question. So we've actually recently done completed a cross-sectional lifespan study looking at age groups ranging from age 18 to 85, I think is the oldest. And we see actually that metacognition about performance is surprisingly stable into old age. So there was a bit of debate in the literature about to what extent this was the case. But our most recent study using large samples has corroborated the hypothesis that actually metacognition is relatively well protected into healthy aging. But that in childhood and adolescence, there's substantial development of metacognition, especially this explicit level, this ability to think about how things are going on the conscious level, emerges relatively late in childhood, so around the age of 4. Before that, you do get these implicit low-level uncertainty signals that are shared with other animals. But it seems that the conscious, explicit capacity to think about how you're performing on a particular task, that emerges relatively late in childhood. It emerges around the same time as theory of mind, which is another reason why we think these might be interlinked.
So is that, did you say age 4 that shows?
Around age 4, yeah. But when I say it emerges, then that's when you can detect it statistically. But it continues to improve through adolescence. And it's not until the age of 16, 17, 18 that people seem to kind of peak at an adult level of metacognitive capacity. And then that seems to be relatively stable for the rest of our lives. Now, what we haven't done is any longitudinal study of the same individual over time. And that's what we really need to be able to do, both early in life, but also late in life, to understand how metacognition changes within an individual, what factors affect that, how it might itself predict future performance. We don't know the answers to those questions because those longitudinal studies are quite difficult to do.
I would imagine. It brings to mind a question around when you're saying it's stabilized around age 18, did you say?
Yeah.
So we've got this phenomenon in the UK, the top 2 killers of young men, motor vehicle accidents and suicide, of which impulsive suicide makes up the number. And so what's happening to metacognition in that age group, which is 18 to 25? Or is that what longitudinal studies would help with?
So it's a good question. I think one thing maybe to keep separate here is what I was describing before as metacognitive sensitivity or self-awareness, as the ability to track our performance from moment to moment. So that's one thing. And then you have this other aspect of metacognition, which I haven't talked about yet, which is known as metacognitive bias, which is just your general level of confidence in being able to do something in the future.
Okay.
And that's what social psychologists sometimes refer to as self-efficacy, or your belief that you'll be able to succeed overall. And that's distinct to how you're able to monitor your performance moment to moment.
Yes.
Right?
Got it.
Now, what we found is that there are big individual differences in both of these quantities. In both of these laboratory metrics of metacognition have individual differences, but they're only weakly correlated with each other. So you can actually be someone who is quite confident as a person, still have good metacognitive sensitivity in the sense that you might be generally very confident, but if something does go wrong, you're aware of that. Conversely, you might be very confident and have little sensitivity. You might have limited self-awareness or insight into your performance. So both of those are possible. Now, and this is now speculation, and we don't have any data on this, but what I imagine might be happening in the case of people taking risks early in life is that your confidence level, you think you're a great driver.
Yeah.
You think you're invincible. You can go and, just take risks on the road. But then if something does go wrong, you are very keenly aware of it. It's not as if you are ignoring the facts there, but you might have this just very strong confidence prior or very strong belief in your ability. And that clearly shares quite a lot of overlap with risk, with your risk appetite. So we don't really know very much about the neural basis of metacognitive bias or how these self-beliefs are constructed. But this is actually something we're just trying to get started in our lab. A new research program is going to look at how moment-to-moment changes in confidence are used, in a sense, to inform and update more global beliefs about ourselves, more global levels of confidence. So that's something we're just getting started at the moment.
So we might apply that to neurological conditions like slow processing disorder, or perhaps we talk about traumatic brain injury.
Well, if you have a TBI, then there's fairly good data from David Sharp's lab at Imperial, other labs as well, showing that if you have a frontal TBI, then you are likely to have diminished explicit metacognition, diminished error awareness. You'll probably lack insight into changes in performance. And there's been interesting work suggesting that might relate to the clinical phenomenon of lacking insight. So you actually might appear in a clinical interview to think everything is going fine. But then when you get home, you might struggle with daily life activities because you're unaware of not being able to perform them. So then you don't seek the help. You don't complain about that, essentially. Yes. And this is known as the frontal lobe paradox, where, if you do have a TBI, it's the frontal lobe. One possible consequence of that is that not only do you perhaps undergo cognitive and behavioral changes, but you actually might lose the self-awareness to know that you're undergoing those cognitive and behavioral changes. And that can be quite pernicious and difficult to diagnose for clinicians because, as I said, they might appear to look relatively normal when you're interviewing them clinically.
Or misdiagnosed for something else like attention deficit. Is it something that can be practically worked on to change?
It's a good question. So whether we could actually improve metacognition itself, so a lot of neurorehabilitation is focused on, understandably, on trying to fix the first order physical or cognitive impairment. But it's an interesting question about, could you actually try and rehabilitate the metacognitive level as well? Now, this is something we're interested in. We've started a bit of work looking at training approaches where you don't only get feedback on your performance, but you also get feedback on how good your metacognitive monitoring is, and you're incentivized to try and improve that metacognition. And that does seem to work in healthy undergrad populations. We can train up your metacognition and show that improvement transfers to an untrained task. So it seems to have generalized benefits for metacognition. But the problem with that is that it seems to be relatively laborious. You need to have quite a lot of laboratory training to get there. The second problem is that, again, there's this subtle paradox of motivation and engagement. If you don't have the metacognition to realize that your metacognition is problematic, then are you actually going to engage in a training procedure like that?
Perhaps it would be something designed for athletes, for example. So footballers and rugby players who get knocked about a bit as part of their usual day-to-day. Our ski racers.
That's interesting. Yeah, I haven't thought about kind of protective training effects, but it's plausible. It could help.
Yeah, that's really of interest to me as well. Then what about social, is it second order or second level metacognition, the social interactions and influences on your metacognition?
So second order, when we use that term, or the way I use that term in the book, it's another word for metacognition, for going beyond the first order cognitive process to reflect on it. But absolutely, we think one of the important functional roles of metacognition is interpersonal. It has benefits not only for our own thinking, but it also has benefits for how we interact with others. And those benefits are twofold. One is that we can communicate accurately what we are thinking about and our confidence in being able to get things right or wrong. That really helps for collaborating with others. So if I'm working with someone on a difficult problem, I want to be able to tell them with a reasonable degree of accuracy what I know, what I don't know, what we need to find out still. Those are all metacognitive judgments about my knowledge base. So I need to have quite good awareness of that to collaborate effectively. We don't want to collaborate with people who are just overconfident and think they know all the answers, because that's going to end in disaster. And so you can clearly see how metacognition is crucial in a social setting. And then the other side of the coin is that, to the extent to which metacognition and theory of mind share some machinery, then we're also not only engaged in metacognition about ourselves, we're thinking about what other people know and don't know. We're choosing who to work with based on our assessments of their competence, of their skill. And again, that can be a difficult problem to solve, because if someone else is projecting overconfidence, if they think they know everything, we might be fooled by that for a while. But we need to have quite sophisticated models of other people in order to distinguish what their actual competence from the way they come across. And so I think those dual roles of metacognition are clearly foundational to creating effective teams.
While you're talking there about, I'm just thinking some of the work I do on a psychotherapeutic level, things like depression or schizophrenia, for example. What I try and do is work with them in building the models that are currently, when they present, they're unconscious. These are things that are created in relation to thinking that they know what the other person is thinking, and it's not necessarily true.
So we don't, in our lab, we don't directly study particular patient groups, but we collaborate with clinicians who study both psychiatric and neurological conditions. Current active collaborations are on depression, on dementia. We're particularly interested in dementia as a disorder where there is clear, especially in the more advanced stages, lack of metacognition, lack of self-awareness. And in the mid to advanced dementia stage, that's where potentially regaining some awareness of potential memory failures can help you protect against the consequences of memory loss. So essentially taking strategic steps to make sure that you retain some insight into what you can and cannot do, and allow allow for structures to be put in place to aid people there. So that's something we're very interested in, about the role of metacognition in what psychologists call offloading. So essentially giving the environment your memory store, or giving the environment your decision-making capability. That's what we do every day when we write a list. We're giving the environment our memory store. And so this notion of offloading, I think, is a really interesting one that seems to be guided very heavily by metacognition, because we need to be aware of potential failure to be able to take advantage of that help. But then in terms of mood disorders, we think that that's also a very interesting and important topic to be working on. One finding that is coming out of that research is that people with mild depression tend to have a lower metacognitive bias, so they tend to generally think their abilities are poorer across the board, but not necessarily any change in metacognitive sensitivity. So they seem to be quite aware of actually doing well sometimes, aware of doing badly. But it doesn't seem to filter into updating this more global self-belief about whether I think I'm going to be able to succeed or not. So that's another line of work we're trying to pursue at the moment, is build models of that linkage and why it might be quite resistant to updating in depression. And I mean, obviously, when you get to severe depression, there may well be changes in self-awareness as well, but that's not, we haven't studied people at the more severe end in our study.
In the second part of your book, optimal self-awareness for learning strategies that could be applied, you talked about student desk and you talked about exam situations. What else?
So I mean, I think having good metacognition about your learning, about your memory, is of great importance in educational contexts in the classroom. There's been some fantastic work by educational psychologists, and this really was how metacognition got started as a field back in the 60s. It was people studying child development who were interested in what children knew themselves about their own learning development, about their own current capacities, and how they were using that self-knowledge to guide their choices of what to do next. And I think, there's been some very interesting work showing that there's this virtuous cycle between aptitude in a particular domain, so what we might want to call fluid intelligence or just kind of raw ability in that domain, and your capacity to self-monitor how you're doing, how you're progressing. And this is work from Simone Getty's lab in children aged between 7 and 12. They've shown that your metacognition, and this is a longitudinal study, so they can see how people should change over time, and your metacognition at age 7 predicts whether you'll grow in your first order capacity in the next year or two. And the implication there is that the kids with good metacognition essentially have the best chance of guiding their own studying, regulating their own learning. Yeah, exactly. So they then get towards a good outcome faster than the kids with poorer metacognition. So there seems to be this whole other influence on development, on performance, that is often neglected in traditional schooling, where we're just teaching people the domain-specific knowledge.
Yes, so I was just thinking that, because what would be useful in thinking about progress, improving or developing metacognition or optimizing it, it would be very interesting to survey, I don't know, different age groups, perhaps age 7 through to 18, and ask the students what they understand self-awareness to be, and cognition, what does it mean to them, and ask the teachers and ask the people that run the schools and develop the curriculum, do they understand that they could improve their learning through optimal self-awareness? I'm not sure.
Yeah.
I think it would be interesting.
Yeah, absolutely.
It would be simple enough to do too, wouldn't it?
Probably, yeah, if you knew the right people to ask. Absolutely.
Well, it would just mean that perhaps taking some of the learnings to make adjustments to what you're doing in the lab to create some programs that could improve metacognition. And for particular age range, maybe we start with the younger ones because that's a good place to start, and particular outcomes so that they've got something to monitor against. At the minute, it is wholly against the curriculum and meeting certain standards, but self-awareness and metacognition is not part of the equation.
No, and I think that's why having a longitudinal approach where you do have objective metrics of metacognitive sensitivity, of confidence level, of self-belief, having these things to be able to track them over time, I think that's the first step. And this is something that we are planning to do. I have a collaborator at UCL, Nico Steinbeiss. He works with in schools. He's a developmental psychologist, and we together are hoping to run at some point a longitudinal study that looks exactly like that, where we essentially start to track metacognition as one of the outcomes that would be interesting to see how it changes and how it relates to an individual's attainment. But also potentially going one step further than that, actually creating a personalized readout of what your metacognition is in a particular domain. Yes. What kind of things are influencing your beliefs in your performance? Yes. Because as you say, in a therapeutic context and in an educational context, wherever you're trying to essentially allow someone to grow, then providing them with information about what might be affecting their behaviour is one step towards actually changing and making more self-aware.
Yes, and having a baseline and understanding why they might do what they do, think what they think,
exactly,
behave the way that they behave, which would be useful, I think, at all levels of the education system, not just for the students. And it's just that the tools, as you say, haven't been there till recently, the last 50 years, and so we have them now. And things like neuroimaging.
Well, I think we find imaging useful not because it's more valid than behavioral data, and in fact, I think the most important data we gather is psychological data, behavioral data. We're psychologists first and foremost. I worry that this rise of the kind of interest in neuroscience is going to erode a focus on behavior, a focus on psychology. I would be sad if it was rebranded as neuroscience that way, but because that is the most important aspect, I think, in a lot of these more applied settings. It's not measuring brain function. It's not neuroscience. It's psychology. And we need to remember that psychological science is a rigorous science, and it's important. And that is where all the applications, I think, are going to come. Now, that doesn't mean that brain imaging is not important, but we use brain imaging to understand mostly how the brain works for its own sake. Like, we're interested in the basic science questions around brain function. But I think it also then allows you to develop new behavioral hypotheses, because you can see how a system might be working. And if we find that particular patterns of brain lesions, for instance, or particular patterns of activation are covariating with a particular variable in our experimental designs, then that gives that particular variable an added status, if you like, in it potentially explaining behavior, because it can be something that we then follow up on and we think maybe it's being coded in a particularly prominent way because it's important for behavior. And so there's a virtuous interaction between neuroscience and psychology, but I think actually a lot of what we've been talking about today is mainly psychology. Yes,
I agree. Reading through your book and looking at your research, the idea of silos, psychology and neuroscience and evolutionary biology and computational neuroscience and computer science, the idea is to unify So that concern about the shiny, sparkly neuroscience starts to come in and take over something that is rigorous science. I agree with you, psychology. Trying to change what's such a traditional view of psychology as, therapy, quote unquote.
Yes, absolutely. And I think the drive for unification and cross-disciplinary fertilization is fantastic. I think we need more of it. I think the worry is that one field tried to swallow up another and swallow it up by replacing its tools as well. And I think that has been something that's happened in the field of neuroscience more broadly over the past decade. And people are realizing it now, and it's starting to self-correct. But there's been a view that simply increasing the power of the tools we have to measure the brain will lead to an exploration of the mind and behavior. And I think we're realizing now that that's not likely to be the case. You need people working on models of behavior. You need people working on models of how the mind works. You need people collecting, questionnaire data, task data, behavioral data. That's a whole field, and it should be cross-fertilizing with neuroscience in really interesting and important ways. But I think the danger comes, and it's mainly actually a resource danger. It's a funding danger. It's that if one side argues successfully for neuroscience being able to solve everything, then it will soak up all the funding. Yes. And it will leave the psychologists and the behavioral scientists without much resource to do what they do.
Interesting. I hadn't thought about it that way. I was excited for unification and removing silos, but with caution.
Yeah, no, I think if it's done with a goal of removing silos, great, I'm all for that. But I think if it's done with a goal of our silo is going to take yours over, and it's less, it's perhaps less productive.
We normally ask for something that you would leave as a message, an interesting question or an interesting next steps for the future.
I mean, I think I would say that we really are just scratching the surface with our understanding of human cognition and how the human mind and brain are working. I think that for me, the most exciting things for the future are what are those elements of the human mind that are perhaps inherited from our culture that make us unique? Because there's a lot of work showing that our brains are relatively similar to other primate brains. They have similar subregions, similar anatomy. A lot of the cross-species work is essentially been telling the story that we're a lot more similar to other mammal brains than we used to think. And that is all good. That's good news, because we can then do translational work. We can work with people studying animal models. We can discover the same kind of computations. We can do the same kinds of experiments. But there still seems to me a blindingly obvious difference that humans have managed to kind of go far beyond other animal species in many areas because we have these higher cognitive attributes. Now, the obvious one is language, that we're able to talk to each other. But there are other ones too that are more subtle, but perhaps just as important. Social cognitive attributes, metacognition, consciousness. And I think those are the really exciting frontiers, and we can only study those things by studying the human mind and the human brain. And I think we're in a great position to now start doing that in real earnestness.
Perfect. Thank you. That's a brilliant way to end.
Good. Cool. All right.
Appreciate it. Thanks for your time.